discuss position of points relative to a line. Relative to a line. Let us say I am talking about the points x1, y1 and x2, y2. And the line that I'll be taking is ax plus by plus c equals 0. Now before starting with the position of points relative to a line, let me remind you of internal division and external division. In the ratios, internal division in m is to n and external division in m is to n. When we derived the formula or when we studied the section formula, we said while the internal division, let us say we have got this line segment AB and this point P divides it into m is to n internally. Now this is internal division. Why is it internal division? Because this point P lies between these 2 points A and B, right? But now consider a situation where this is the line segment AB, and the point P is on the extended portion of this line, or you can say outside of this line. Now this point P, if point P divides AB in m ratio n, then that would mean AP is to PB is m is to n. Now this is internal division, this is external division. How do we differentiate these two? By saying that this ratio is considered negative because we are going outside of this line, right? We are going outside of this line and then here, and in this division we are going inwards. Okay, so this ratio is positive when AB is being divided by this point P internally. We take this ratio m is to n as a positive ratio, and m is to n is considered negative when the point P divides AB in m is to n externally, right? So basically this is the difference in internal division and external division, right? Saying this, now let us draw the coordinate axes and think about a line and these 2 points. Let us say this is the coordinate axis that I am talking about, and this is the line ax plus by plus c equals 0, right? And this is one of the points, this is another point. Let us say, considering this point as x1 y1 and this point as x2 y2. Okay, I should have written this point above it. Okay, just so that the diagram is clear. All right, so this point is x1 y1, this point is x2 y2, and this is the line that we will be talking about. What I want to know is, let us say there is this line. If I've got 2 points on the opposite side of this line, right? One on this side, another on this side, or or these 2 points are on the same side of this line, whether on this side or on this side. So I want to know the position of points relative to this line. Okay, let us first of all join the points x1 y1 and x2 y2 and consider this point. Let us say this point divides this line AB in m is to n, right? Of course this is internal division, right? This point, let us say, divides AB in m is to n. So what will be the coordinates of this point? You know that the coordinates of this point will be mx2 plus nx1, mx2 plus nx1 divided by m plus n, and y coordinate will be my2 plus ny1 divided by m plus n. So these are the coordinates of this point here. Now what is this point? This point lies on line L, right? So if it lies on line L, then these coordinates will satisfy this line. What I mean to say is, if I replace x and y with these coordinates, it will satisfy the line. So a x coordinate mx2 plus nx1 divided by m plus n, plus b into y coordinate, that is my2 plus ny1 divided by m plus n, plus c is equal to 0. Okay, once you have got this, now let us simplify it a little bit. So to simplify it further, let me write it like this. I can write it like m ax2 plus n ax1. This m plus n and this m plus n I can take outside and multiply it with this, or what you can say is m plus n can be multiplied with this c, and on the right hand side it will become 0. So the right hand side remains 0 and this term will become m plus n into c, and here this term, this second term, will become m into b y2 plus n into b y1 plus m plus n into c. So let me collect the terms with m in them. So this is one of the terms, this is another term, and I'll get one term from here. So if I take m common from everywhere, I'll have ax2 plus by2 plus c. And similarly, if I take n common, I'll have ax1 plus by1 plus c from here, and it will be equal to 0. Now you can imagine, if I take one of these to the right hand side, I can write m divided by n as minus ax1 plus by1 plus c divided by ax2 plus by2 plus c. So now this, the numerator is nothing but the line when we put the point x1 y1 in the line, right? And this is nothing but the point x2 y2 put in the line, right? And there is this negative sign here. Now see, m by n is equal to minus of this expression, negative of this expression. So for m by n, for m by n to be positive, for m by n to be positive, this expression in the bracket should be negative, right? Because there is a negative sign outside. For this term on the left hand side to be positive, this expression inside the bracket should be negative, because then negative negative will become positive. So for m by n to be positive, ax1 plus by1 plus c divided by ax2 plus by2 plus c should be negative, right? Another thing, for m by n to be negative, the expression inside the bracket, that is this expression, should be positive, because there is a negative sign outside. So for m by n to be negative, I'll say ax1 plus by1 plus c divided by ax2 plus by2 plus c will be greater than 0, right? Now what do we mean by that? We have already discussed that m by n is positive when the division is internal, right? Internal division. And we take m by n to be negative in case of external division. So consider this, if these 2 points are on the opposite sides of this line, let us say one point lies here, one point here. Now which line we are talking about? Ax plus by plus c equal to 0. So when I put x1 y1 in this line, and when I put x2 y2 in this line, now see, for this to be negative, we should have different signs of this expression and this expression. Numerator and denominator should have different signs. If one is positive, the other should be negative, right? If one is negative, the other should be positive. That means there is internal division, right? This line divides them internally. So these are on opposite sides of the line, right? And here these should be on, these should have the same sign. This, what is this? This is L x1 y1, right? And this is L x2 y2. So when we put this point in the line and this point in the line, these should have the same sign, right? and they should be on the same side of this line, because this time the division is external. This point divides the join of these points externally, right? So they should have same sign, or they will be on the same side of the line that we are talking about. So once again, if we look at the diagram, once again let us look at the diagram. See, this line here divides this join of points A and B internally in m is to n. So m is to n is taken as positive when the points are on opposite sides of the line, or this line divides the join of these points internally, right? M is to n is positive, right? So we can say when m is to n is positive, the points lie on opposite sides of the line. So when m is to n is positive, this expression inside the bracket has to be negative, because there is negative sign outside. So for this expression to be negative, what will happen is the numerator and denominator should have different signs. Okay, so when the points are on the opposite sides of the line, then line and the point value of the line at these points will be of opposite signs. Okay, if the value of the line when these points are put is of the same sign, then they lie on the same side of the line. I hope this much is clear to you. Let me write some questions here. So the question is, are the points 3, 4 and 2, minus 6 on the same side or opposite sides of the line 3x minus 4y equals 8? So the line that we are talking about is 3x minus 4y minus 8. Now, if I put 3, 4 here, what will be the value? 3 into 3 minus 4 into 4 minus 8. So this is 9 minus 16 minus 8. So 16 and 8 is 24, and minus 24 plus 9. So this is 9 minus 24, which is equal to 15 with a negative sign. So we have got this as negative 15. Now let us see 2 comma minus 6. What does it give? A negative value or a positive value? So when I put 2 and minus 6 in place of x and y, I'll get 3 into 2 minus 4 into minus 6 minus 8, which is 6 plus 24 minus 8. So this is a positive value for sure, which is 22, right? So L 3 comma 4 and L 2 comma minus 6, what does it mean? L 3 comma 4 and L 2 comma minus 6, that when I put 3 and 4 in place of x and y in the line, so these are of opposite signs. So of course these are on opposite sides of this line 3x minus 4y minus 8 equal to 0. Okay, let us see if I've got some other questions. Find the set of positive values of b for which the origin and the point 1 comma 1 lie on the same side of the straight line. Which is the straight line? This is the straight line. Do not get confused by a square or ab. This is a line in x and y, so powers of x and y are 1, right, for all a belonging to real numbers. So now this origin, that is 0 comma 0, and the point 1 comma 1 lie on the same side of the straight line, that is this line. So let us see L00. What will be L00? If I replace x and y with 0, 0, there will be only 1 here, which is greater than 0. Now if I put 1 comma 1 here, I'll have a squared plus ab plus 1, and it should be greater than 0, right? It should be greater than 0. Now it is mentioned in the question that a belong to real numbers. Okay, and you see this is a quadratic expression in a. This is a quadratic expression in a. which is always positive, greater than 0. So if a quadratic is always greater than 0, right, it doesn't touch the x-axis. That means its discriminant is less than 0. So the discriminant of this quadratic expression in A for all real A is negative, right? And what is its discriminant? B squared minus 4ac. So that means b squared minus 4 should be less than 0, right? So you can write this as b minus 2, b plus 2 should be less than 0, and for this the value of b should lie between minus 2 and 2, right? It should lie between minus 2 and 2. All right, I hope this question is clear to you. Now let me write one more question. Before going to the next question, there was one more point which I missed in this question, that we need to find positive values of b, but these are all the values of b for the given condition. So positive values of b will be after this 0, right? So 0 will not be included, and 2 is of course not included. So these, for these values of b, these positive values of b, the conditions will satisfy. Okay, let me write one more question now. In this question, there is a point a square comma a plus 1 which lies in the angle between these two lines. Okay, let us say there are two lines and this point lies here, a square a plus 1, containing the origin. That means the origin or the point 0 comma 0 is also here, right? So what can I say about this point and this point? These 2 points lie on the same sides of both lines. So if origin lies on this side of this line, this point is also lying on this side. Origin lies above this line, so this point also lies above this line. So whatever, let us say I take these lines as L1 equal to 3x minus y plus 1 equal to 0, and L2 as x plus 2y minus 5 equal to 0. So whatever value I'll have for 0 0 for this line L1, positive or negative, so a square and a plus 1 when put in this line will give me the same sign of the value. So let me just solve the question and you will come to know. L1 at 0 0 will give me 1, which is greater than 0. So this point a square a plus 1, when I put it in L1, a square a plus 1, I already know that it will be positive. Why? Because origin and this point lie on the same side of line L1. So let me see what, when I put this in the line L1, what is the expression that I have? 3a squared minus a plus 1. So a minus 1 plus 1. So this is the expression that I get. This can be cancelled. From here I can say 3a square minus a is greater than 0. So I can take a common, right? Or 3 also I can take outside. So it will be a minus 1 by 3 greater than 0. So if I talk only about this expression, so I have got a into a minus 1 by 3 greater than 0. So what will be the solution of this? That this solution will lie, one of the critical points is 0, another point is 1 by 3, and their product is greater than 0, right? So they will, the solution will lie either on this side or on this side, right? So it will be, the solution for this will be a belongs to negative infinity to 0 union 1 by 3 to infinity, right? So this will be the solution for this first condition which I have derived from the line L1, right? Because these 2 points lie on the same side of L1. Now let us think about L2. So this is line L2. So what will be L2 0 comma 0? It will be equal to minus 5, which is less than 0. So I already know that L2 a square into a square comma a plus 1 should be less than 0. And what is it equal to? So whatever it is equal to should be less than 0 for these 2 points to be on the same side of L2. So if I put a square comma a plus 1 in L2, I'll get a square and then a plus 1. So it will give me 2a plus 2 minus 5, right? So I've got another condition, which is a squared plus 2a minus 3 less than 0, right? So let me factorize it for you. A squared plus 3a minus a minus 3 less than 0. So it will be a plus 3 a minus 1 less than 0, right? And for this inequality, the solution will be, the critical points are minus 3 and 1, right? And 1. And for it to be less than 0, the solution should lie between these 2 points, minus 3 and 1. Or let me write the solution. A belongs to minus 3 comma 1 for this to be true. Now I want these two conditions to be true simultaneously, this one as well as this one. So for that, I'll have to take the common solution of both these, right, conditions. So I'll have to select the intersection or the common part of the solution. So which is minus 3 to 0, because this portion is common, minus 3 to 0, and this portion will also be common, 1 by 3 up to this one, right? So how do we write this? Let me make some space here, or let me change the color. So the solution will be a belongs to minus 3 to 0, because this is the portion that is common to both, right? And then union 1 by 3 to this, up to this point, 1 by 3 to 1. So these are the values of a for the given conditions. I hope you have got the idea of position of points relative to a line and its probable usages.